Alright, this is the friendly review for my pre-calc class. We're going to start off with some synthetic division. First thing I want to know is P over Q. So it's going to be the back constant over the front coefficient. So that's 6 over 1, factors of 6, plus minus 1, plus minus 2, plus minus 3, and plus minus 6. All over the factors of 1, which is going to give me plus minus 1. Now I'm going to set up my synthetic process. I put the little backwards box, and then I put the coefficients 1, negative 4, 1, and 6. And this is a cute little trick that we use with the Casio. And it's going to generate the 3 answers rapidly. So I'm going to turn it on and hit mode. 5 for equation. 4 because this is a cubic equation. Now I'm just going to enter these coefficients that I use for the synthetic process. 1 equals, it slides over. Negative 4 equals, it slides over. 1 equals, and it slides over. And I entered a 6, and now it's going to give me these answers from the rational roots. So my first answer is negative 1, my next answer is 3, and my last answer is 2. I like to put them in order, so I changed up the batting order. Now, I take those solutions, and I use them in my backwards box. So I take this negative 1, and I bring it over here. And I put my negative 1 in that backwards box. And I implement the synthetic division process. 1 plus 0 is 1. Negative 1 times 1 is negative 1. Be careful in your arithmetic. This is going to add up to equal negative 5. Negative 1 times negative 5 is positive 5. 1 and 5, that equals 6. I'm in my remainder column now. Negative 1 times 6 is negative 6. This gives me a remainder of 0. And that's what's nice about using the technology to get the correct answers. All I'm doing now is showing my work. Now I'm going to test my second answer, my second solution, my second root, my second x-intercept, which is 2. I'm going to put it in another backwards box, and then go through the synthetic division process again. 1 and 0 is 1. 2 times 1 is 2. I'm going to be careful on the arithmetic. Negative 5 and 2 gives me a negative 3. Set up my remainder column. 2 times negative 3 is negative 6. So remainder equals 0. Now I'm going to rewrite this as a broken down algebraic expression. Basically, this means x minus 3, and I set it equal to 0 to find out where that x-intercept is. When I solve that, notice I get x equals 3 if I add 3 to both sides. And that's my final answer over here. Number 2, this one's a bigger one. I have negative 60 for my p and positive 1 for my q. So I'm just going to put 60 over 1, and then the factors of 60. Plus minus 1, plus minus 2, plus minus 3, plus minus 4. 4 goes into 60. 5 goes into 60. 6 goes into 60. But 7, 8, 9, 10, that goes into 60. 12 goes into 60. And then 15 goes into 60. Need to lengthen this line. And 20 goes into 60. 30 goes into 60. And last but not least, 60 goes into 60. All over the factors of 1, which is plus minus 1. I'm going to start the synthetic process. I'm going to write down my backwards box, but I don't know what goes in it yet. I'm going to bring down the coefficients. 1, negative 12, 47, and negative 60. I'm going to cheat up on the Casio. It's always nice to have. So I'm going to hit AC to clear that out. And then I go to 5 for equation, and 4 because it's an x cubed. And that wants the coefficients, or these numbers from the synthetic process. So I have them there. I have 1, negative 12, 47, and 60. So for A, I put the 1. I hit equals and it moves over. For the B, I type in negative 12. I hit equals and it moves over. For the C, I type in 47. And it moves over to the last spot, D, which is negative 60. And it's going to give me the 3 answers. So my 3 answers over here are going to be 3, 5, and 4. And I'm going to write them in order. So I have 3, 5, and 4. 3, 5, and 4. So I'm going to write 3, 4, and 5. The first number I'm going to put in my backwards box is the 3. I'm going to go through the synthetic process. 1 plus 0 is 1. 3 times 1 is 3. Negative 12 and 3 is negative 9. Then 3 times negative 9 is negative 27. When I subtract those, I get 20. I multiply 3 times 20, and I get positive 60. Remainder, 0. I'm going to set up another backwards box for synthetic. And this time I'm going to put the 4 in. 1 and 0, that's going to give me 1. 4 times 1 is 4. Be careful in the arithmetic. Negative 5. 4 times negative 5 is negative 20. This gives me a remainder of 0. I'm going to algebraically set this up. I'm going to add 5 to both sides. And that's going to give me x equals 5. And I can get the y-intercept rapidly. It's right there. It's that number hanging off at the edge. So the y-intercept is going to be 0, 84. I go up on my y-axis, and I'm just taking a shot at it there. Now I'm going to find my zeros, not by synthetic, but just by using this. So I hit AC to clear it out. Then I'm going to type in the coefficients. 1, then 14, then 61, then 84. I hit equals again, and it's going to give me those answers. It takes a while. One of my answers is negative 7. Another answer is negative 3, and another answer is negative 4. So negative 3, negative 4, negative 7. Negative 7, negative 3, negative 4. I'm going to write it down in this order. Negative 3, negative 4, negative 7. Now I'm going to plot them on my graph. So I go to negative 1, 2, 3, and put a dot. Negative 4, put a dot, and negative 5, 6, 7, and put a dot. Now x squared, or x cubed, rather, we should know is going to look like that. So it has to start down here, go through, bend again, and now I'm aiming for that y-intercept. And that's just a cheesy graph of my cubic. Another one, first thing I want to close in on is that y-intercept. Notice the y-intercept here is negative 21. So it's going to be 0, negative 21. Now I'm going to plot that on my y-axis. I'm going to find the zeros using my technology. I'm going to do mode 5, 4. Now I'm going to type in the coefficients of this, which are 1, negative 11, 31, negative 21. 1 equals negative 11 equals 31 equals negative 21 equals. My first answer is 7, then 3, then 1. So I'm going to write it down in the order of 1, 3, 7. 1, 3, 7. These are my x-intercepts. So I go over here and I put a dot, a point at 1, a point at 3, and a point at 7. Remember, x cubed looks like this. So it's going to start through here, go high, through, bend around, come back up, and go through. X squared. So there's a couple of ways to do this. I'm going to rely on the calculator. I could do it by hand, but I just want to try to get the technology out of the way so we have other options. Now notice this is a squared, so I'm not going to hit mode 5, 3, 4. I'm going to hit mode 5 for equation. And notice this is x squared. This is x squared. So it's going to be 3. In the same process, it wants the coefficients. So I have a coefficient of 1x squared, then a coefficient of, try again, 1 x squared, then a coefficient of 4x, and then a constant of 3. I hit equals, and it gives me x-intercepts. One of the x-intercepts is negative 1. Another x-intercept is negative 3, so I can graph those. Now what's nice about this, the y-intercept, that's easy enough. That's just the positive 3 at the back end, so my y-intercept is going to be 0, 3. We can always get that quickly. Now the vertex. If I hit equals again, it gives me the x val minimum for the vertex. If I hit equals again, it gives me the y value minimum for the vertex. Now with this information, I can graph the parabola very accurately. So I have a y-intercept of 3, 1, 2, 3. An x-intercept of negative 1. An x-intercept of negative 1, 2, 3. And a vertex at negative 2, negative 1. And I can use symmetry if I wanted to go through there and graph the parabola. And notice it fits in the pattern of 1, 3, 5. From here I go up 1 over 1, up 1, 2, 3 over 1, up 1, left 1, up 1, 2, 3, left 1. I'm given the zeros, so now I want to write a polynomial with the given zeros. So if negative 5 is a solution or a 0, x plus 5 is going to be a linear factor. X plus 2 is going to be a linear factor. Now I'm going to set up the Punnett, x plus 5. You can FOIL it if you want. X plus 2. X times x is x squared. X times 2 is 2x. 5x, 10. Combine like terms. This is going to give me x squared plus 7x plus 10. Factorization of this, so if a 0 is negative 2, a linear factor is going to be x plus 2. If negative 1 is a 0, x plus 1 is a linear factor, and x plus 3 is a linear factor. So I'm going to put the x plus 2 on this side of the Punnett, the x plus 1 on the top of the Punnett, the x plus 3 on the side of this Punnett, and what goes up here is the answer to the guts of the other Punnett. So x times x is x squared, x times 1 is 1x, 2 times x is 2x, 2 times 1 is 2, so the x squared goes up here, combine like terms, 3x and 2. X times x squared is x cubed, x times 3x is 3x squared, x times 2 is 2x, 3 times x squared is 3x squared, 3 times 3x is 9x, 3 times 2 is 6. These usually combine on the diagonals, which is nice. And now I'm going to CLT. That's going to give me x cubed plus 6x squared plus 11x plus 6. This one's a little bit of a whopper. I already have it set up for you. Just trying to get you to put your brain around the arithmetic. Okay? So I'm going to multiply this times this, and I set up the 9 squared Punnett. X times x is x squared. Excuse me, negative 11x. Negative x root 2. Negative 11x. Negative 11 times negative 11 is positive 121. Positive 11 root 2. Negative 11 times negative root 2. This is going to give me positive x root 2. This is going to give me negative 11 root 2. And then root 2 times root 2 is 2, but a negative times a positive. A negative times a positive is a negative 2. Now I start to notice that things will eliminate on this. The negative x root 2 and the positive x root 2. They cancel out. The positive 11 root 2 and the negative 11 root 2 cancel out. So now I'm going to CLT, combine like terms, and the x squared comes out by itself. And then I look for something that simplifies or combines with negative 11x, and that's going to be negative 11x. So that gives me minus 22x. Now I want to see what else combines, and the 121 and the negative 2, they also combine. So 121 minus 2, that gives me positive 119. I want to graph each equation. I begin at 1, so if I put mx plus b, I begin at y-axis 1. And my slope is 2 over 1, so I go up 2 over 1, up 2 over 1, up 2 over 1, continue the process on the other side, down to left 1, and then connect the dots. Mx plus b again. Mx plus b, I begin at positive 1, 2, 3, and my slope is up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, down 1, left 2, down 1, left 2, and then connect the dots. Y equals x. That means it should be written, like, could be written as 1x plus 0, so I begin at 0, and then I go up 1 over 1, up 1 over 1, up 1 over 1. And then continue the process on the other side, down 1, left 1, down 1, left 1. Vertex form. I need to find the vertex, and the vertex of this is going to be the opposite of that, which is negative 2, the same as that, negative 4. So I plot the point negative 1, 2, negative 1, 2, 3, 4, and that's my vertex. Now I implement 1, 3, 5. So from there I go up 1 over 1, up 1, 2, 3 over 1, up 1, 2, 3, 4, 5 over 1. Go back down. Up 1, left 1, up 1, 2, 3, left 1, up 1, 2, 3, 4, 5, left 1. And then I connect the dots. Now the parabola. This time the vertex is going to be located at 1, negative 1, 1, negative 1. I go right 1, down 1. And I implement the 1, 3, 5. I go up 1 over 1, up 1, 2, 3 over 1. Go back down the vertex, up 1, left 1, up 1, 2, 3, left 1. And now I'm going to connect the dots with a gentle curve. Next one. Find the vertex. Opposite same. 3, comma, negative 4. So I go right 1, 2, 3, down 1, 2, 3, 4. Implement the 1, 3, 5. From this vertex, I go up 1 over 1, up 1, 2, 3 over 1, up 1, 2, 3, 4, 5 over 1. Go back down. Up 1, left 1, up 1, 2, 3, left 1, up 5, left 1. Connect the dots. This one's a little trickier. I could use the calculator in mode 5, 3. So I hit mode 5, x squared, this is an x squared, so 3. I hit enter, whoa, I didn't enter the stuff. I have to type in 1 equals, negative 2 equals, and then negative 4. And then negative 4 equals. So when I hit equals again, it gives me an x-intercept that's a radical. I hit equals again, it gives me an x-intercept that's a radical. I don't want to graph those. But it gives me the x value minimum of the vertex, which is 1, and the y value minimum, which is negative 5. So this has a vertex of 1, negative 5. I go to 1, negative 5. I go to 1, negative 5. Write 1 down 1, 2, 3, 4, 5, and I implement the 1, 3, 5. So I go up 1 over 1, up 1, 2, 3 over 1, up 1, 2, 3, 4, 5 over 1. Go back to the vertex. Up 1, left 1, up 1, 2, 3, left 1, up 1, 2, 3, 4, 5, left 1. And I connect the dots. Y equals x squared goes through 0, 0, 1, 3, 5. Up 1 over 1, up 1, 2, 3 over 1, up 1 left 1, up 1, 2, 3 left 1, and the rest of the coordinates will take me off the graph. Y equals x cubed. That's going to be 1, 7, 19 instead of 1, 3, 5. So I start at 0, 0, I go up 1 over 1, I go up 1, 2, 3, 4, 5, 6, 7 over 1. Then I go down 1 left 1, down 1, 2, 3, 4, 5, 6, 7 left 1. And that's the shape you get.